all of your questions in the Q&A panel.
And just a quick note, you said put all your questions in chat. Please put your questions in Q&A, and then if you need to talk to us, panelists, please use chat. Thanks, Kristen.
There we go. Yeah, what she said. All right, so the team on the map here, you can see this is the technical field engineering team. We do have with us today, we have Miss Echo Rantanen and myself, Kristen Hudson, and Raquel Martinez is back with us today, along with Simeon, although his name is going to look a little bit different on the panelist option. Just so for those who don't know, this team here on the map is the ones who bring you IPD Week. And here are the dates for the IPD week for this fiscal year. As you can see, we are in our last group batch of IPD sessions for this week. It's May 3rd through the 7th. All of the other sessions that you can see here, we will have available in the IPD course. Now, this is for instructors only. So if you are a student, you must ask your instructor if you'd like to view anything. Here you can see we have the IPD sessions that we have coming up for this week. On the right-hand side, we do have the list of all the sessions that are upcoming. So we do have the new LMS options for you and how hackers think. Now, for this IPD week, we do have some special sessions, and this is going to be one of them. So these are the sessions here from Netacad to Network Engineer. This session that we're doing today, we have Wi-Fi 6 and 5G and real-life examples of wireless deployment. So these are the sessions that are going to be available for students as well as instructors. All right, when you go into the IPD course, you will see this is the home page. So just as a quick reminder, if you want to view any of our previous sessions, we do have the November and December sessions that were completed along with February and all of the registration links that are available for the ones upcoming this week. And with that, we are going to swap presenters, and I'm going to introduce you to your presenter today. With us today, we have Bradley Riapolov. I really hope that I said your last name correctly. He is a technical solutions architect for Mass Scale Infrastructure Group with Cisco. I'm going to go ahead and give you the ball, Bradley. Set up your desktop. We'll go ahead and get started.
Right, Kristen, thank you. Can you see my screen?
I certainly can.
Fantastic. So folks, very nice to meet you. My name is Brad Riapolov. Like Kristen said, I'm a technical solutions architect for Cisco Systems. I've been in this field for about 20 years, half of them on the customer side and half of them working for different vendors. I've been at Cisco in diverse roles, and I think it's most appropriate that I cover this topic for you. I've spent years of my career deploying both Wi-Fi and radio networks all over the world. So I've had a chance to observe how this technology has developed over the years and where we are now. Again, questions, let them go into the panel since I cannot see your questions. But what I'll do is at about 7 minutes until we end, I will stop. And if there are any live questions that you would like to ask me, or maybe that were not answered during the Q&A session on the chat window, we'll be able to cover those as well. So there's me, there's my name, there's my contact information right there at cisco.com. I love talking to different people. So if you don't know me, reach out. I'd like to know who you are and what you do. But today's session is focused on Wi-Fi 6 and 5G and how these technologies are different. What we're going to do, we're going to dispel myths and marketing and separate marketing from reality when it comes to these two technologies and help you understand what is the current state of these frequencies. Where do they stand, right? How do we deploy them as customers? What exists to help us? And even we'll put on a technical hat at some point in our presentation to help us better understand how these technologies work. What is under the covers? So with that, let's get started. If you never heard of Wi-Fi 6, or at least Wi-Fi 5, Wi-Fi 4, Wi-Fi 3, you'll be very much like myself. As I said, I've been doing this since year 2000 when I started out my networking career. And I can tell you this, 3 years ago, when I heard the term Wi-Fi 6, I was really surprised, because even though I've been dealing with the technology for about 15 years, I stepped away from it for a couple of years. And when I heard 6, I never heard of 5 or 4 or 3 or 2 of 1, right? What exactly happened? What did I miss out on? So if you feel like myself, understand you did not miss out on anything. There are 2 different organizations. There is the IEEE. This is the institute that is responsible for creating the standards, different technology standards. So the standards for wireless technologies started with 802 dot something. So for example, if you had 11B since 1999, right about when I started in the networking field, and then it progressed to G, 11G, and then maybe you've heard of AG, 11AG right around 2004. In 2009, 11N technology, and many of you have routers at home that probably support this type of technology. And then in 2013, the new standard was introduced, AC. So that's what IEEE organization does. It's responsible for the standards themselves, and their latest standard is 802.11ax. There's also a second organization, this Wi-Fi Alliance, and you can go to their website and find out what they do. But the difference between these two is that these folks are responsible for the standards themselves, whereas the Wi-Fi Alliance makes sure that there is interoperability between the vendors when it comes to these technologies. So for example, you can buy an access point from Cisco, but how do you make sure that that access points can talk to a competitive product? Maybe it's a Mist product, maybe it's a Ubiquity, right? Or maybe you're using a client that potentially can be connecting to different potentially can be connected to a different access point. Now, how do you do that? Well, the Wi-Fi 6 Alliance is going to take care of that, right? That's the compatibility, the interoperability between different products. And Wi-Fi 6 was a marketing name that this Wi-Fi Alliance came up with, and then backward filled in other technologies like Wi-Fi 5, Wi-Fi 4, Wi-Fi 3, Wi-Fi 2, and Wi-Fi 1. So these technologies never existed in this proper form back when they back in the day, right? So you can think of them being as anachronistic terms, right? They existed before their time. So you did not lose out on anything. It's just that an easy way to market a particular technology. So if you're looking at 802.11ax and Wi-Fi 6, essentially they're one of the same, but they're referenced by 2 different organizations. You can see that the ratification was done for Wi-Fi 6 was done by IEEE in 2020, and Wi-Fi 6 Alliance completed their certification as in 2019. So this technology promises lots of different things. There's lots of marketing behind this, and you can see that there are some of the things that Wi-Fi 6 or 802.11ax bring to the table. Basically, high efficiency, which we will examine. There's 4 times the capacity in this IoT scale. There's one other piece that keeps popping up, is the 6E standard, right? There's a lot of misinformation. There's a lot of marketing in this space. And the one thing to know about this 6C is not a new standard by any means. It's an extension, a marketing term for the coined Wi-Fi 6 standard, which is new, right? This extension, essentially what it promises is opening up an additional space, depending where you are around the world, in the frequencies to support these new radios. So for example, in the US, where I am based out of Houston, Texas, FCC is the organization that apportions frequencies for radio use. And what they're going to do, they're wanting to allow 1200 megahertz frequency, a new frequency that will support this extension, Wi-Fi 6. It'll use the same technology as Wi-Fi 6, but it'll be available in different space. Right? That space is going to be unlicensed, and that's what's going to happen in the Americas, in the US. Now, in Europe, there's a similar effort that is underway where 500 megahertz of frequency is going to be made available in the same, in about the same frequency, the same space. So that's just an extension. The one thing to remember about this, that this 6E standard, lots of hype around it, is not going to be backward compatible with the present standards and the ones that had come before it, right? So that's one thing to remember, simply because it works in a different part of the spectrum, right? So you gotta have to have a different antenna, different radio that is able to talk about this. So anything that you have today, any of the Wi-Fi access points or any of the clients that can speak Wi-Fi 6, right? They have to be upgrading meaning new hardware to be able to speak Wi-Fi 6E. So that's one thing to remember. Now, where's Wi-Fi 6 or 802.11ax? Well, it's happening now, right? This rollout has been out for about a couple of years, and you can see that in 2020, you can see there's the first FCC orders that have gone in on the 6 gigahertz spectrum where the 6E extension is going to go into, right? And you can see that in 2021, which is where we are now, the first Wi-Fi 6 capable, Wi-Fi 6E capable consumer APs are taken, that are showing up. And then you can see that the greater expansion is going to take place in 2022, right? We covered with you that it's Wi-Fi 6E represents the additional 1.2 gigahertz frequency, right, the spectrum width, with no interferences, because there's pretty much nobody in that space. There are in the US, there are some water utilities, some of the industrial networks potentially operate in that space. And FCC and Cisco are working closely with each other to make sure that nobody's stepping on each other. But it's a wider bandwidth that is going to be made available to the public in this unlicensed space, and certainly unused. So there's lots of opportunities that will be taking place there. Higher throughput, because we have these wider channels that are being available to us, and this ultra low latency, right? Very low time to get between the radio of the client and the access point itself. So just know that Wi-Fi 6 is here now, and 6E is coming on board very shortly. Now, we're going to rewind back from the 6C back to Wi-Fi 6, or 802.11ax, and find out what is the myth behind it. I mean, what is the real story? Well, number one is the higher data rates, right? So you can see that there's an incremental increase in terms of that, in terms of throughput. For example, 9.6 gigabits per radio, that is 802.11ax radios are capable of pushing out there, and a single antenna speeds of 1.2 gigabits. We will increase we have increased the spatial streams, which we will cover during this presentation. And we also have enabled this next generation high definition video that this standard is going to support. Overall, there's an increase in network capacity. So when compared to previous standards, you get 3 to 4 times more throughput than you had in the previous, this 802.11ac or Wi-Fi 5 standard. Why? Via this technology, OFDMA, and we'll explain to you how it works. We're reducing the latency, right, and we're increasing the greater reliability, right, and also we're improving the power efficiency as well. So we'll discover how that works also. All right, so let's take a look at this. What is this chart showing us? This chart, and I'd like to point out a couple of things here. Cisco runs this mobile World Congress that takes place in Barcelona. We did not do it last year because of COVID, but these are historical trends that are shown here for 11AC. So this is Wi-Fi 5, not Wi-Fi 6. But the reason I'm showing you this is to drive an important point here. So take a look at this. It takes us 3 years to be able to get to the point where most of the clients that are visiting this Mobile World Congress in Barcelona are populated with Wi-Fi 5 or AC. So for example, AC standard is introduced right here, right about 2014, 2015. And you can see that the first year that we ran this, they're only 35% of the clients were AC, right? The next year we went to 40, and the next year we went to basically almost 70%. So the majority of the clients at this world event were AC clients. So it took about 3 years from the inception of the standard to the adoption itself, right? Right. What does that mean? Well, that means that the greatest efficiency that the history shows us that we've seen from the Wi-Fi 5 clients is when the majority of your clients on your network are going to be Wi-Fi 5 or AC, 11 AC, right? Why is it that way? Well, take a look at the data exchanged here. In the first year, when we only had 35% of these clients, we exchanged 17 terabytes of data, right? Next year, when we added to 40%, right, we went to 27 terabits. And then finally, when we went with the majority of the clients became AC clients during this Mobile World Congress, we tanked about 29 terabits of data. At the same time, look at this, the utilization stayed flat. So I'm adding a lot more clients, I'm adding a lot more data that I'm pushing through, but I'm hardly ever increasing my utilization on my network, right? So it takes about 3 years to see the benefits of this. The same thing is true of Wi-Fi 6 or 11.ax standard as well. Why? Because the biggest benefits you're going to see is in the fact that the majority of the clients of your network are going to be Wi-Fi 6. So if you're still running some of the older Wi-Fi 5, Wi-Fi 4 type of technologies, these benefits are not going to be realized until the majority of your clients convert, because that's where you're going to reap these type of numbers, right? So remember this, the Wi-Fi 6 standard itself helps you most when you have lots of clients, lots of people on your network. That's where the biggest benefits are going to come from. I have an example to give you. For example, at my house, I only have 4 or 5 people that are using my bandwidth, right? So for me, Wi-Fi 6 is not going to be a big benefit, even though lots of people are pushing lots of different data through my router. Why? Because I need a whole lot of devices and a whole lot of users putting a lot of bandwidth on my network for me to be able to see the greatest benefits. And you will see that through the rest of the presentation itself. So the history kind of shows us what can happen in the future. These are the stats for the Wi-Fi 5 standard. So Wi-Fi 6 is following in the same way. All right, now that you can kind of understand the trends behind Wi-Fi 6 and what you can see here, what is 5G? Well, 5G, again, this is cellular broadband data. And if you've been around like myself, you can see that it started out in the 1980s, where it was called the 1G, in the 1990s, the 2G, 3G. This is when I first got my first iPhone, right? And we were running around downtown Houston measuring the throughput, and kind of the same thing that people are doing now with their newest 5G phones, right? And you can see that 4G came around 2010s, and then in 2020, 5G showed up. Every single technology, every single iteration of this technology comes with big marketing hypes. It's going to solve all the problems. It's going to end some of the other technologies. And I can tell you, I've lived through every single one of these cycles. And every single time, there are some expectations that have to be lowered based on the marketing that has been given to us, right? And that's something that I'd like to cover here. So in the 5G by the numbers, right? You were talking about the cellular broadband now. Yes, these data rates are quite impressive. I've seen the videos of people kind of running around New York and Boston and some of the European cities trying to see, oh, here's my video playing. It's definitely there. It's a lot faster. The second one that is being promised is this 1 millisecond latency. Now, I will tell you this is a stretch. Be careful with this number, because what they mean here is that from your radio, for example, from my phone to the tower, that latency can be 1 millisecond. But that's not the latency that my client is going to potentially need. We're talking about end-to-end latency, and that's going to be a lot higher. From the first introduction of the 5G technologies, I've been working with the world's leading companies that are trying to take this 5G spectrum and put it into their private use. And I will tell you, this number is not achievable. The very best of them, right? These are the airlines, the automotive industry. They can get to about 7 milliseconds with really, really heavy customization, right? But typically, you're going to see a latency in about 10 millisecond range. So this is kind of hyped up. Be very careful with that. It's nice to get this type of latency from my phone next to my tower that can be really close to me, but realistically, it's going to be a lot more than that. Quicker downloads for sure. Coverage is definitely there. Availability, reliability, we will get there. And then supporting for these high-speed deployments is a reality as well. All right. What's the next one? So what spectrum does the 5G use? Well, here's the entire spectrum. So if you're thinking of Wi-Fi, we built this out. So it's fully, if you're thinking of Wi-Fi 2.4 gigahertz, right, that's where going to be 5 gigahertz, the newest Wi-Fi 5 or AC standards are going to be like right around here. But if you're looking for 5G, there are different bands that are covered here. There's the low band, there's the mid band, and there's the high band, right? And the way that it works, and you can look at these slides on your own, that there's a correlation between data rates that are available and the coverage area and the penetration. So all the way on the left hand of the spectrum, if you can think of what exists here, right? These are going to be your, in the US, for example, there are the FM and AM radio waves. These waves are hundreds of meters long, and they travel for hundreds and hundreds of miles, and they penetrate pretty much anything, right? They can go through trees, they can go through buildings, they can go through animals, they can go through people. But with that advantage comes one big disadvantage. Anything that is on this side of the spectrum has very little data rates, right? Very little data that can get through. As you get, for example, in the wireless spectrum, like a 2.4 gigahertz or 5 gigahertz, these waves are going to shrink about the size of your antenna, about 6 or 12 inches, right? They will have better penetration of let's say buildings, and they can shoot the signal not maybe as far for hundreds of miles as in the AM radio, but however, they can go through certain walls, they can go through certain buildings, right? And they certainly increase their data throughput. Now, by the time you get into these millimeter waves, which we were covering in the next slide, what you have is the very opposite of what you had on the left-hand side. These millimeter waves, I mean, they're really, really this tall. They're very small. And they have very good throughput, very high throughput. That's why you're able to get these 10 gigabit data rates. However, their penetration and their reach is very poor. Right? So for example, if you have lots of foliage, or if you're going through rain, or if you're going through buildings, that's going to be the disadvantage. So the difference of understanding how this 5G spectrums work is in the way of understanding that you have this dilemma between waves that can go very far and have very little data throughput, or waves that don't go very far at all but have this tremendous throughput, right? So watch out when you're looking in this millimeter wave, because high data rates, yes, but very low coverage, very low penetration. That means you're going to have more antennas, more infrastructure support to be able to drive these signals. Okay, what is private 5G? I talked about some of these companies, airline companies, manufacturing companies that are creating these frameworks. What do they exist from? What does their private 5G network consist of? Well, you have the devices themselves, right? This can be your cell phone, end user cell phone, or maybe it's a user equipment that needs to talk to the network. They get on this regulated spectrum, right, licensed spectrum, and they join this radio network, or RAN, radio access network. These are going to be cell towers to which these devices are going to talk to. Now, these cell towers are going to land this signal terrestrially, right, put it on Earth, and via fiber or Ethernet or GPON or some kind of a technology, they're going to connect you to the mobile core network. Mobile core is essentially where I'm going to take all these devices that have come in through my radio transport, and they have joined my core, my network, and I've allowed them there, right, via my policy, access policy, and I also control where they can go and what they can do. And typically, this component is provided by a product called Mobile Packet Core. Right? For example, Cisco is one of the vendors that sells this type of offering. Essentially, what you can do is you can get your devices, put up your radios, and then use this Mobile Packet Core to onboard these devices and join it to the rest of your network. That is private 5G. So the question now comes often, Does 5G replace Wi-Fi, or does Wi-Fi 6 replace 5G? No, it's not going to happen, even though there's lots of hype around the marketing of the specific 5G vendors that are saying you no longer need Wi-Fi. That's not going to happen. There are use cases for both, and most of the time it's going to be a conglomeration, or joining together of both of these technologies. And this slide shows you here some of the use cases for private 5G. So for example, if you're trying to cover a wide area, like we discussed with those waves, well, maybe Wi-Fi 6 won't be able to do that. If you have a very large automotive warehouse, Wi-Fi 6 potentially can struggle with that, right? So you're going to have this type of network to be able to do that. Right? At the same time, you will have some networks that are far easier installed and managed with Wi-Fi rather than 5G. And you can see here digital health and maybe digital campus. And there'll be something in between, right? If I'm running automated guided vehicles on a track and testing them, how they work, well, is it going to be 5G or is it going to be 5.6? Maybe it's going to be a mix, right? If I am given an enhanced mobile broadband experience with particular downloads, well, you have to judge which technology works best, right? All of them have their pros and cons, and you as a customer have to figure out how to make them work together. Costs definitely being one of them, and that's something that you always have to consider when you are approaching these solutions. All right. In terms of a timeline, reality check, right? The marketing says 5G is on the rollout, the Wi-Fi 6 is swallowing up the world. Where are we? Well, you can see that Wi-Fi 6 is a little bit ahead. So in 2018, I believe it was like September of 2018, it was either a company called Ubiquiti or Mist. I can't remember which one of them, but they introduced the first Wi-Fi 6 access points. 2019, just about 6 months from that, I remember Cisco we put up our first access points in Wi-Fi 6. We studied it in the universities all over the US, made sure that by the time that this technology has rolled out, that we had some stick time with it, right? And now in 2019, 2020, we started receiving these full-featured IPs all over the place, and 2020 definitely saw this massive expansion of clients. I mean, they were going into everything, into iPhones, into Samsung, Androids, all over the place, right? So it's here. Wi-Fi 6 is here. Now, 5G is going a little bit slower. You can see that they began fixed wireless here, right? And in 2020, some of the carriers began to roll out this technology. So it's definitely here. But when it comes to the rest of the world, 5G is lagging behind. And that's typically expected. Just know that Wi-Fi 6 is here and it's ahead. All right. Now that we understand this, let's put on our technical hat, and I'll try to make it as simple as this as possible here. And I've called this section Wi-Fi 6, or might as well be 5G, because the technology is essentially the same. They're using the same or similar frequencies and similar methodologies behind these frequencies. So Wi-Fi 6 for 6-year-olds, so to speak, right? How do we increase this on-air efficiency? Well, take a look at this. In order to have this high efficiency wireless, whether you're doing it 5G or whether you're doing it Wi-Fi 6, you're going to have several of these things. The first one is the data rate. Sorry, advanced a little bit too fast. The first one is the data rate, the modulation. What is that? Think about this. When the radio communications first began, one of the engineers in Europe, Marconi, right, the alleged inventor of the radio, he sent a signal across the Atlantic Ocean of letter S, which was the Morse code. He went ... That's letter S. That's an early example of modulation, right, specifically encoding. Well, it takes a long time if you were to do it Morse code letter by letter. So over the time, the mathematicians have come up with really creative ways on how to pack more of these bits, right, into the signal itself. So you can transfer lots of data, not just Morse code, not just letters, but video and voice and such, right? And the latest one of them, and there were several of them, there was a QPSK, PSK, like different ones, but the latest one is this QAM, this quadrature amplitude modulation. It's essentially means how many bits I can put on air in a single symbol, right? So what you see here in the 802.11 AGN standard, you could put 6 bits in a symbol. What they're doing, they're taking this matrix and they're dialing down, they're introducing this higher modulation. So now in 802.11ac or Wi-Fi 5, you have 8 bits that you can put on a symbol. And now in Wi-Fi 6, right, 5G, using the same technology, you can put 10 bits per symbol. So your data rate efficiency is increasing because with the same signal, you're just putting in more data in there, and that's how they're able to get these 9.6 gigabits through the radio. The second one is number of spatial streams increasing. If you were listening to me, and I know I'm throwing a lot of data at you, we said that we can do 8 by 8 spatial streams. That means how many streams can I send out to my network from a single radio? Remember this, that radio is a half duplex medium. It's not like Ethernet, right? On Ethernet, I can go full duplex. I can send and I can receive at the same time. It does not work like this in the radio spectrum. In the airwaves, one person talks at a time, right? Everybody else has to listen and say, okay, now there's free airtime. Now I can talk. So by increasing the number of spatial streams gives me the ability to have multiple people talk at the same time, right? So the more of these streams I have, the more data, the more talk time, airtime I can give to all the people that are a part of my dynamic wireless network domain. Then you have this channel bandwidth, right? Channel bandwidth is essentially, here's a single channel, 20 megahertz, right? What I can do is I can combine these. I can do 20 and 20 and I can get a 40, a wider channel. I can combine these 40s and get an 80. What you can get here as well is you can combine these 80s and have a single channel that is really wide, meaning lots of data, 160 megahertz, right? There are some other downsides of using this, right? If somebody else is using these channels, well, all of a sudden we have a problem, right? But it's possible in a lab-based environment when there's no interference, nobody by me, to create these type of scenarios for high data rate throughputs. And so when you're reading these data sheets for all of these Wi-Fi 6 and 5G radios, understand that's what those data sheets are built for, right? Best use case scenario. Sometimes they're not possible, right? But there are times when this spectrum is clear. So that's what comprises this. The last one is just essentially the protocol overhead, right? Transporting my signals. That's fine. So now that we understand that, what they're doing here, let's look at a couple of these, right? So you have this term OFDMA, right? And I'm highlighting A. Why does it matter? So OFDM, this orthogonal frequency division multiplexing, if you're familiar with time division multiplexing, this orthogonal frequency is just far more sophisticated. And what they've done is, like, say, you take a 20 megahertz channel, right, and you're looking at it in a spectrum analyzer. In OFDM, which came before Wi-Fi 6, right? We've had this for a while. You had it in NAC. What they've done is they take this channel and they break it into these subcarriers, right? And a user, when a user is using, let's say, sending traffic onto the airwaves, every single channel can be given to a user. Well, that's kind of nice. And OFDM did a good job. They had this spacing that they introduced, and basically you could put 64 channels in this OFDM frequency. Right? That means 64 people at the same time. Well, that's kind of nice. Now, what have they improved in OFDMA? This is orthogonal frequency division multiplexing, and this stands for access. Right? What they've done is they have narrowed down this spacing right here, which took these 64 channels to 156, right? And they also decided to say, you know what? This single lane, this single channel, instead of giving it to one user, we can give it to multiple users as well, right? And they call these resource units. So multiple users can exist on the air, can use the air at the same time. Now, how do you visualize this? The picture that I showed you in the previous slide is right here. That's it at the top, just for reference. But look at every single one of these channels. So you can think of them as swimming lanes. This is the old way. OFDM took a single swimming lane and says one user per this swimming lane. So if you think of in terms of trucks, here's my truck, I'm carrying this load, right? This lane belongs to me, but I might not be using the entire truck for my load. Maybe I'm not backing up my data. Maybe I'm just sending voice traffic on a little email. Guess what? I still take up the entire lane. The truck is still not full. Right? So what they're doing in OFDMA, they add this concept of resource units. Right? They say instead of having only one load per truck, I'm going to put multiple loads into this truck. Right? I'll give resource units to each individual packet. If I were to do this, this empty space would disappear, right? And because of that, my resource utilization will go up. Spectrum efficiency goes up because I can put more data on the air at the same time than when I had it in the OFDM space. All right, that's fine. How does that work, right? Well, let's take a look at it without the trucks. Again, here are the swimming lanes, right? This is the old way, OFDM, and you have slot 1, slot 2, slot 3, and so on and so forth. Here's one user. He's doing telemetry. The other one is doing, he's talking on the phone. Somebody else is doing video. Somebody else is doing data. Somebody's driving IoT. Sorry. Single lane per this traffic. In OFDMA, you subdivide this. So for example, this lane is going to be occupied by user data of number 7 and also by another user right here. Right? So I'm stuffing these channels with as much data as possible. That makes me much more efficient. That's great. You can think of it as this is a US highway that is full of trucks, right? There's congestion here and some people are getting off simply because there are too many trucks with all these loads. Well, think about this. What if we were to really take all these trucks, eliminate the empty space, fill it up with all the freight that goes into these, right? Put them into this sort of a chain or train of a truck, right? And thereby eliminate some of the congestion that exists on our airways. That's exactly how OFDMA works, right? How these resource units work. Now, in practice, what have we seen? Well, take a look at this. The chart is very simple to understand. You have Wi-Fi 5 in blue right here, right? And we're showing here the linear voice delay. So for example, in this case, if you're following the blue part of the graph right here, and at the bottom, you have the client count. By the time you get to about 35, 40 users on a single AP with Wi-Fi 5, what you get is this latency that grows to 100 milliseconds, right? That's about the threshold of an acceptable conversation. So as you begin adding users here, you can see that at 400 milliseconds, nobody's talking on this access point. Just absolutely impossible. When we took the same number of users and put them on a Wi-Fi 6 access point, guess what? We had it at 80 users and the latency was still at 50 milliseconds. That's the efficiency of the crowd that I was telling you about in Wi-Fi 6, right? Very, very efficient because we can reuse the air talk time quite more efficiently. Look at the data side of this. So this is voice, right? Look at the data. So we're again in Wi-Fi 5 in blue, right? We have about 10 users and our throughput is terrific, 50 megabits. As we start adding users and get to 40, the throughput for everybody is decreasing, right? Wow, that's very unfortunate, right? By the time you get to 80 users, there's nothing taking place here. The throughput is minimal, unusable. Look what happens in Wi-Fi 6. Yeah, there is a little bit of a ramp up here, right? But even though at 80 users, the throughput is not really decreasing, right? That's interesting. Something else interesting to point out, if you've been around this technology, the ramp up itself is better on Wi-Fi 5. See that? It immediately starts out at 50 users. So for Wi-Fi 6, it takes a little bit of time to build up, but overall, it's far more effective. Okay, here's another example. Here's an example that is done with 25 users in a classroom, right, that are using voice and video. And you can see they're right here, right? Again, Wi-Fi 5, by the time you get to 40 users, you get to have problems. But in this case, they increased the number of users to 50, right? And you can see that the latency is more than acceptable. Here's something else. If you're interested in a lower jitter, right? Statistics are the same. And there's also a packet loss rate. Statistics are very, very similar. So that's kind of the advantages. One other thing to point out here, if you've heard of technology called mGig, right? That's the ability to carry more than 1 gig of data through the existing copper cabling, right? So if you have an mGig capable endpoints, for example, Wi-Fi 6 access point and an mGig capable switch, you can put through much more data. And that's what's shown here. So at the bottom, you have a Wi-Fi 6 performance with a gigabit switch only, right? So you took this AP, you hooked it up to the switch, and you can see that you top out at just shy of a gig worth of traffic, right? 900 megabits that you're putting through that port. However, if you have a switch that is capable of doing this multi-gig technology, multi-gig ports, that you can see here is different speeds that we're clocking. Like for example, using dual radio here with 2.4 and 5 gigahertz, 2 gig being clocked through that 1 gig port, right? Or 1 gig cable. And then also that's a simultaneous throughput for 10 different users, 1.5 gig. So know that Wi-Fi 6 really works well with the mGig ports on switches that are capable of doing that. All right, so we've taken care of the throughput. Let's take a look at the parallel processing really quick and some of the enhancements that were done in Wi-Fi 6 versus Wi-Fi 5. Multi-user MIMO. So if you have not seen this, it's really simple. This is a single user MIMO. Remember, we talked about radio being a half duplex medium. We can only send, one person can talk at a time. So in time, at first we have the single user MIMO. You know, you have a radio, it talks to one person, waits till the next one. So multiple streams, you can send it to one client. What multi-user MIMO has introduced is the ability to send multiple streams to multiple clients. That's pretty interesting. Like, so for example, in this case, you have the ability to send 3 spatial streams at the same time. Okay, what does that mean? Well, you can have different combinations of that. You can send one stream to one user, another stream to another user. That's one combination. The second one, you can do, you can send a stream to every single user, right? Or you can send one stream to one user or 2 streams to another user. So multiple combinations exist, right? Now, we're going now to, in Wi-Fi 6, to the ability of doing 8 streams at the same time. That's far more efficient, right? That's definitely something to consider. Now, multi-user MIMO, and this is not specifically Wi-Fi 6, this was introduced in AC, is the ability to have this multiple radios, right? The reason you run these multiple radios is because you get into the concept of beam steering, right? Beam and null steering. If you think in the US highways, this is kind of where I live, you have these trucks that travel the interstates, and they have 2 radios, one to shoot forward to see what the signal is, to shoot the signal forward, right? And one to shoot the signal back. On the sides, there's nothing, they're just fields, so not really important. But these are the 2 radios that you see typically on the trucks. Now, on the antenna, what we've done is we've put up 4 radios now. And 4 radios back and forth gives us the ability to put that signal anywhere. This is going to be quite efficient because now what I can do, I can really either amplify my signal or I can nullify, cancel that signal. That comes at a great efficiency to me. And the way to think about this is I've tried to explain it in the past to my girls. And, you know, when they're playing a jumping rope, if you have 2 people that are holding each of them is holding the end of the jumping rope. And if they create a wave that goes in the same direction, that wave will amplify, right? So if you're both going clockwise, it's going to be a really big wave. You amplify the signal, you make it stronger. That means you can direct that signal to a particular part of your radio spectrum. If at the end of that rope, you are doing this signal or creating the wave in the opposite direction, so somebody goes clockwise and somebody goes counterclockwise, that wave will cancel each other. The rope will not go anywhere. You're nullifying that signal. So with this technology, what you can do is, if you're seeing on this graph, you can amplify a signal for a particular user. So if I know a user 1 is here, user blue is here, I can amplify this blue signal toward him by using this beam steering. Right? At the same time, I do not want the user blue to receive the red signal, for example. What I'm going to do, I'm going to nullify, you know, clockwise, counterclockwise, the signal toward that user. That greatly improves my efficiency to be able to focus the signal on a particular client. Now, this is done here for the illustration purposes only. Don't think that if the users are sitting like this in a stadium or a theater, that's not possible. However, it's a representation on what can be done on a relatively spaced portions of aiming my signal. All right. What are some of the enhancements that we have introduced to multi-user MIMO in Wi-Fi 6? Well, multi-user MIMO, that ability to send multiple streams to multiple clients, can now be supported in the uplink, in the downlink, as I'm receiving data, or maybe I'm uploading the data. We talked about the 8 multi-user MIMO streams, right? It used to be 4. That's really important. So these are good things to remember. Now, this was a deterministic LTE to Wi-Fi handoff with Wi-Fi 6, and you are beginning to see some of the areas where essentially the 5G and the Wi-Fi 6 technologies begin to play together, right? They can interwork with each other. They can hand off the signal. So, for example, you can be on a 5G technology, and now the networks are able to take you off that transport, put you directly on the Wi-Fi without introducing a reauthentication or things of that nature. So this is definitely becoming possible with the solutions that can be integrated together. The next one is the IoT enhancement for Wi-Fi 6. So the benefits here are in the fact that more and more IoT devices are coming online every day, and there is still a strong need for 2.4 gigahertz spectrum. That's something for you to remember, that now with a lot of clients that have moved on to the 5 gigahertz spectrum using those radios, this 2.4 gigahertz spectrum is no longer a junk band. It just simply needs to work, right? And it has a lot better spectrum utilization and coexistence with some of the other technologies that I'm mentioning here, for example, Bluetooth and Zigbee. And if you're in the industrial type of AT, like I'm here in Houston, which is the US capital of oil and gas, we definitely see a lot of these technologies that are taking place there. All right, the last one to cover here is this target wait time. Right? Target wait time is an ability to provide an effective mechanism to schedule transmissions in time for up to 5 years. You say, why? What does that mean? Well, that means simply that there are devices that are coming on the market that are so battery efficient, right, that the battery will last that long. And so if I can have a protocol to, let's say, wake up a particular device in 5 years from now, so May 4th of 2026, right? That's exactly what the standards calls for, right? Is it possible? We'll see how that works out, but that's exactly what the standard calls for, is this target wait time. It's really, really efficient of use of a device that may be dormant for a long period of time. Okay, with that, Cisco products for Wi-Fi 6 as I'm watching my time here. Cisco's been in this game for a long time. You can see our autonomous access points were introduced in 1999, and all sorts of proliferation of different technologies that we have introduced over the years. And Wi-Fi 6 is being the latest one of them. Now, if you wanted to build out the Cisco networks, there are multiple products that are available. There's a Catalyst 9100 series APs that support these Wi-Fi 6 technologies. There's also Meraki access points as well. We go into these new Catalyst switches, and you can see kind of the whole framework of access switches, core switches, and the wireless controllers that support this infrastructure. If you are interested to see what Cisco's got, here's one quick slide on this. Essentially, we have these Catalyst 9105s, the smaller ones, 9115s, 9120s, 9130s. They all grow in capacity, throughput, spatial streams. Like, for example, you see this 9130, I mentioned 8x8 radio. That's here, but may not be in some of these other access points. And the latest offering from Cisco is Catalyst 9124 outdoor Wi-Fi 6 AP. There are some controllers that are available on this as well, and some of these access points will run a controller on the AP without sacrificing it for just being a controller. It can run a simultaneous function. If you wanted to take a look at some of the statistics, right, this is when we introduced the products. For example, this one does 4 spatial streams, right? There's the 8 spatial streams and so on and so forth. Not all of them do all of the features that are present in some of the higher end ones. So I always watch out for these, what's possible, what's not possible. But some of them have integrated antennas, some of them have external antennas, and so on and so forth. So kind of be careful here. All right. And there's some of the stats regarding how many clients they can support and what they can do. I decided to include this one. This is the latest one from Cisco, the 9124 outdoor AP, 4x4 spatial streams right here with all of the technologies that we've discussed with you, downlink and uplink OFDMA, Cisco RF ASIC, and some of the other stats on how much power it consumes and so on and so forth, and where it is available. So take a look at this as well. This slide really here, if you are using Cisco Meraki cloud-based Wi-Fi solution, know that they have a full wide assortment of products that they run as well for that. So if that consumption model fits you best, you will definitely find lots of capable products that are supporting this technology. And as far as controllers go, we have a ton of them as well. I mentioned to you the embedded wireless controller that runs in the AP, and it can handle up to, you can see right there, 100 APs that are surrounding it. Very nice. So you can save a lot of money on this. If you are going up in scale and you need a bigger number of APs being supported, well, here's kind of where they are. You have different offerings, whether they're on a Catalyst switch or maybe there are Catalyst controller that runs these, and you can certainly run these in the cloud as well. And they'll support your distributed branch, small campus, medium campus, as well as large campuses as well. They scale really, really well. The last slide that I'm going to show you here is something really interesting that I saw. So if you've been dealing with a wireless technology, you know how you have these spectrum analyzers. They've always shown you this 2D view, two-dimensional view. Here's a wireless 3D spectrum analyzer that Cisco is going to release later this year. And take a look at some of the previews. I thought this was really, really incredible. You get to look at your campus or your facility, and you can sort of see where your cell coverage pockets are, where some of your worst covered area are in a 3D form. I thought this was really, really interesting. I'm looking forward to seeing that being available. So this is it. This is my last slide. I thank you kind of for your time listening to me. I told you that I would leave you 7 minutes to ask any questions that may not potentially have been covered by our capable Q&A team. So with that, Kristen, can you kind of help me understand where we are with the questions, and if there's anybody
I can take that,
like
Brad. This is Echo.
Okay, Echo, yeah, that would be helpful.
Yeah, so thanks for a great presentation. I know you're located here in the US, in Texas. A couple questions have come in a little bit about some of these technologies in other areas across the world. Do you have any insights? For example, somebody was mentioning Africa or Mexico. I don't expect you to have to know that, but just wondered if you had any insights as far as kind of adoption and how it's going.
Yeah, no, the great question. As I said, and I have, I'd like to think that I have worldwide visibility of what's taking place. Right? Obviously, some of the continents are going to be lagging behind. Right? So kind of watch for that. The one thing that I keep noticing, particularly when you're not located there and you are supporting some of these locations, that's one thing to watch out for, because there are some governing bodies that are regulated by the countries where they are in, and some that roll up to, for example, the European regulatory bodies, right? And so you got to be real careful to find out, okay, which access point do I need in which part of the world, right? And so Cisco has tools, and other vendors also have tools that are called wireless domain locators. You will essentially go in and dial in, take the product SKU that you have, that you need, you think you need, one of the access points that I showed you, right? You will go in and you will go into that tool and you will look up that particular locale. So let's say you're in Ghana or you're in Nigeria or somewhere else. Well, what's the regulatory domain for that space? And you will see whether a vendor supports it or not. Now, just because the vendor does not list it does not mean that you cannot deploy it there, right? If it's listed, you're good. Okay, -I or -C, this is my domain. They all go by letters. I've run into the situations where it's basically not there. right? And the customer is asking, hey, which one do I deploy? At that time, we ask customers, direct customers, to work with their, they have government representatives that they deal with within their locale and help them understand which domain they should be using, right? And I've had multiple customers, like for example, out of the UK, but they're working in Angola or where they're working in Trinidad, right? They go in and they use their own UK-based domain within that particular locale. So that's the one thing that I would watch out for. I would say Wi-Fi 6 is going really strong in Europe, US, obviously, Australia. When it comes to these other countries, it's going to be hit or miss, right? But that's kind of where we are today, Echo.
Perfect. Another question that we get occasionally are safety issues or concerns around 5G. What are we talking or telling customers as we work on this implementation?
Yeah, great question. So there's a lot of buzz around that and has been for years. 5G is bad for you, 5G is good for you. I can tell you conclusively, nothing has been proven. That's just the way it is. The way that it's explained a lot of times is that the millimeter wave is so small and it cannot penetrate skin and all that other stuff. I will tell you this, I do not think it's an unsafe technology. That's one thing. But any exposure to RF is certainly harmful and something that you really have to watch out for. Back in the early 2000s, when I started working with this, I was working with the Cisco AirNet 350 bridges without any antennas on them. I could tell you, I'd come up with them, it'd make me sick. Right? Literally, I'd go turn them off, I'd be fine. So I know that RF exposure can be harmful. However, that's in really, really close proximity. The RF exposure that you receive from your cell phone is far greater. A lot of you are sleeping with these cell phones without 1 meter or 1 yard distance from you. What you are getting from this is about 1 milliwatt worth of power. That's a lot. You're gonna get 5 million times less exposure from a wireless client. Right, so understand this, put this away from you if it's kind of possible. From a Wi-Fi standpoint, it's not as bad, right? Simply because they're dialed in a little bit lower. But all in all, opinions differ on this, kind of be your own judge, but I do not think this is a harmful technology. Just know that any exposure, prolonged exposure to RF the effects of that are unknown at this time, right?
Thank you. Great answer. Yeah. We have time for a couple more questions. The other thing we've done is we've started a poll on the right-hand side. So you should be able to see the poll. This is basically just some feedback. What do you think of the presentation? Also, we have a topic list in there. You know, if you're interested, what other things would you like to see? We do have a mixed audience of instructors and students. So thank you for joining us today, especially the students. The first time we've opened this up. And Brad, great presentation. There's a couple other questions we'll kind of finish up with here. We're not going to quite get to all of your questions. Thanks, everybody. We got stormed with probably 50 right here at the end, Brad. So we'll get to a few of them. Will customer adoption rate, what will customer adoption rates be within 3-year horizon, considering there's no backward compatibility and possible high implementation costs?
Yeah, that's a great question. I would say the past is the best predictor of the future. It took us 3 years to get to mostly Wi-Fi 6 clients. I'm sorry, Wi-Fi 5 clients. Those are 802.11ac, like I showed you in the beginning of my presentation, from 2014 to 2017. It's going to be the same for Wi-Fi 6. It's going to take about 3 years, right? As far as 6E, it's just beginning. And I hear so much silly talk. Like, for example, 2 years ago, I first heard of Wi-Fi 6E. And customers were already asking me, well, when will Cisco things be ready to do Wi-Fi 6E? And I'm saying, this is so early. Calm down. You know, technology takes a little bit of time to develop. Take a look at what Apple is putting in. take a look at what Samsung is putting in, right? And that'll give you the best gauge of what to do yourself as a customer. For example, those two organizations that I mentioned to you, IEEE or Wi-Fi 6 Alliance, go to their websites. Educate yourself. Don't listen to what other people tell you. Those websites are so plain and clear to read. For example, on the Wi-Fi 6 website, you can go and we don't have time right now, but if you were to go to their main page, there will be a link for all devices that are Wi-Fi 6E certified by that alliance. So that'll give you an idea of how to gauge the developments in this space, right? Because I remember rewinding 2 years ago when we were at Wi-Fi 6, and I went and I looked there. There was a bunch of HP Aruba access points there. There were some Cisco's in there. There was Mist. There were some other people. And then there were chipsets that were going into the individual cell phones, right? Or individual clients. And I'm looking at this, I'm like, well, we're just in the beginning stages. Now you go in there, that list is like full. A week ago, I went and looked at 6C. There are some things in there, but not a ton of them, right? So watch that space, educate yourself. That'll give you a good gauge to understand where you are. But my estimate is going to be 2-3 years from the time of inception. It cannot go any faster than that. The big, huge manufacturers have to put in these chipsets in, and companies like Cisco and our competition have to make it available to the market. Understand, we have to do our own testing. At Cisco, we can't just say, here's a chipset, Mr. Customer, you have it tested. Everything is broke. Well, Cisco gets a bad name. So we need a little bit of time to go into these universities, put up these technology, work with these, let's say, manufacturing companies that are going to put in the 6E technology in, test it out with them, see what works, what does not work. That is going to take 6 to 8 months. We collect that data. Then we give you a solid product. So it takes time to catch up, 2-3 years. Watch that Wi-Fi 6 page. It's a really great resource to keep ahead of the game.
All right, thank you. We'll end with that since we're a couple minutes over. Thanks everybody for your questions. We didn't quite get to everybody. We'll pull more experts in. Usually with instructors, we're able to keep up with session questions, but with over 500 attendees here, we missed a few. Also want to say, if you guys are students joining this session, you will need to get both the recording and the slides through your instructor. We don't have a place at this point to post these, so we'll post these within 24 to 48 hours of this session in what's called the IPD Week class. So contact your instructor and say, hey, could you go out to the IPD Week class? We'll make the slides available in a PDF format, and then the recording will be streamed. Your instructor will have access to it. It won't be downloadable for about 2 weeks. So thanks everybody for joining. With that, Kristen, I'll hand it back to you. I think we still have the poll running. And thank you, Brad, so much. I love your easy to understand style. That really helped.
Great. Thank you for the feedback, folks. I hope we do get to do this again.
Fantastic. Thank you, Echo. Thank you, Bradley, so much. This was a wonderful presentation. Lots of great feedback. So many people saying thank you for the information and the valuable session. So looks like it was a hit. Thank you.
You're most welcome.
And we have another session coming up in just under an hour. So you saw some of the technology. We're going to have another Cisco employee talk to us about real life examples of the wireless deployment. So different campuses are going to do different case studies. So now that you've kind of seen the technology, let's look at how would we deploy, current or older technologies along with some of these newer technologies. So thank you, everybody.
Perfect. All right, guys. For those of you who still have not completed it, we do still have the poll running. There's about 2.5 minutes left for the poll, so please take that. We do read all the feedback and appreciate all the information that you provide us.
And if for some reason it went away, you can click on those 3 little dots in the bottom right corner to see the polling panel. So you might have been flipping back and forth between chat and Q&A, and it might have gone away on you.
Thank you, Echo. And for those of you who would like to view the YouTube link for the broadcast that we are doing, we have posted the link to the YouTube in the chat. So you can go and view the chat and you should find the IPD playlist link there. And with that, we have just under 2 minutes left of the poll. Please remember to do that for us. We greatly appreciate your feedback.
And Krista, you usually do this anyway, but let's save chat and Q&A. Might be interesting for Brad just to see what some of the questions popped up.
Yeah, I love reading through those. I said my customers.
There's a bunch.
My customers
Yeah.
are the best place to learn this technology because you get to see what they're experiencing. One of the things that I noticed, vendors create products, but customers don't necessarily use them in the same way. There has to be some understanding what the customers are doing to future develop our products, right? To understand what the use cases are. So I love reading these type of questions.
Great point.
Perfect. All right, and Simeon's going to go ahead and stop the recording for us, so we will have that available for you. We do post the recordings and the slides usually about 24 to 48 hours after the session has been completed. So like Echo said, we will have that in the IPD course. Students, please ask your instructor for a copy if you'd like to view it again. And I'm going to go ahead and save the chat and Q&A for us. And there's about 30 seconds left of the poll. So if you haven't completed it yet, please go ahead and do so.
One person had asked how many people had